Good afternoon. My name is Mahdi Al-Husseini, and along with Joshua Burnett, we are the Aura Training Systems product. We are here for the Purdue Business Model Competition. Thank you for listening to our presentation.
Hello, ladies and gentlemen. My name is Joshua Barnett, and I am presenting Aura Training Systems along with my partner here, Mahdi Al-Husseini. So as I said, I'm Joshua. I'm a PhD student in mechanical engineering at Stanford University and the FRG group.
Hello, everybody. My name is Mahdi Al-Husseini. I completed my master's degree at Georgia Tech in computer science with a focus on artificial intelligence, and I'm actively completing my other master's degrees both at Stanford and at Purdue in aeronautics and astronautics and electrical engineering, respectively. Josh and I have worked together for a long time. We were actually good friends in high school and later undergraduate freshman year roommates at Georgia Tech. A couple years ago, we also started our first company together called Salus, which is a reaction wheel-based stabilization system for helicopter hoist operations. We were recognized by the National Inventors Hall of Fame in 2019, and our company was acquired by another company, Vita Inclinata, in 2020. So a little bit about what I do on a day-to-day basis. So this is me, and I'm here at Wheeler Army Airfield in Hawaii, where I'm stationed, and I'm in front of one of our helicopters here at the medevac. This is an HH-60 Mike Sikorsky Black Hawk. And as shown by the red crosses, it is my responsibility to evacuate soldiers off of the battlefield and take them to hospitals where they can get the care they need. Now, whether you are a military pilot like me in the medical evacuation space, or you're a private pilot who flies Cessnas for fun, at the end of the day, the mark of an excellent pilot is in your ability to perform maneuvers. Now, maneuvers can be any number of things, depending on what it is that you fly and do. They can include auto rotation, steep turns, and even combat maneuvers, as shown as with the Apache on the right-hand side. Improved maneuvering flight leads to fewer pilot-induced accidents, improved handling of mechanical failures, such as an engine failure, and increased mission success, whether you perform medical evacuation, water bucket operations, cargo hoists, etc. So the question becomes, well, how can you get better at maneuvering flight if that is so important? And the answer is pretty straightforward. You fly. In the words of Chuck Yeager, the best pilots fly more than the others. That's why they're the best. And you'd be hard pressed to find an aviator or a pilot who would disagree with that. On the other hand, flying is prohibitively expensive. So for example, the 2021 cost of a single flight hour in a UH-60 Black Hawk is estimated to be around $4,200. And even if you're not flying an advanced aircraft like the Black Hawk, even if you're flying a Cessna, those costs can absolutely rack up, especially with the amount of flight time required for you to go out and get your private pilot license, commercial license, etc. And so there have been a number of flight alternatives that have been introduced in order to reduce the amount of time spent in the aircraft. Now, these simulators can include something like the Microsoft HoloLens, actual software that you would pull up on your laptop, and more typical flight simulators as shown on the right. But at the end of the day, in the words of Yoshi Kono, a Chief Warrant Officer 3 at my unit, simulators, they aren't bad for training instruments and introducing the cockpit to newbies, but they sure don't fly like real aircraft. And so the problem is as follows. Actual in-aircraft flight time is expensive but critical. Simulators provide a great deal of valuable raw and processed information, but they lack the realness found by flying a real aircraft. Aura improves training so as to reduce the total amount of time required to master maneuvers in real aircraft, and does so in a manner tailored to training manuals specific to both military and civilian flight. And so to take a look at what we are proposing, assuming, for example, the Black Hawk, if we were to go from something called an RL3 to RL1 progression, which is a requirement for aviators to perform the full range of their duties, typically this would take 40 hours. If we were to assume that the technology we're introducing was able to reduce even 20% of the total amount of flight time, we would be looking at savings around $33,600. And similar results are here provided for something on the civilian side on a more hobbyist level. But even $2,500 in the case of somebody trying to get their private pilot license is incredibly meaningful. And so the purpose of what we are introducing is efficient flight training, capable pilots, and safer skies. Using a pipeline of computer vision and machine learning tools, Aura provides maneuver-specific process data to pilots in real time during flight without needing to physically connect to the aircraft. Aura can support any rotary or fixed-wing aircraft.
So what we have here is a patent-pending solution that consists of two parts. So we have a mountable camera system and a custom iOS application. The mountable camera system features computer vision and neural network-powered character recognition software. This allows us to actually recognize where the specific instruments are on the panel and then transcribe the data that it's reading out This can then be downloaded directly into the custom iOS application, post-processed, and then visualized directly to the user. This allows us to provide immediate task-specific feedback to pilots and as well as the instructors, and we can also annotate as to whether or not a maneuver was performed successfully or within parameters. And so what we have here to the left is actually a video demonstrating our current proof of concept with our current neural network model, showing that we have fairly good transcription ability in terms of transcribing the numbers shown in the individual instruments. And this will continue to be refined as we collect more data. And then here to the left again is another video showing our custom iOS application, which gives you access to specific maneuver parameters that might be held within a PDF that's accessible within the application, as well as allows the user to actually visualize the data downloaded directly from the mountable camera system. In terms of the market, we have a large market in the United States. There's over 660,000 pilots in the United States, and what is of particular interest to us is the 113,000 certified instructor pilots, as well as over 197,000 student pilots in the United States alone, according to the FAA on the civilian side. And on the military side, there's over 18,000 pilots in the Air Force, 14,000 in the Army, 7,000 in the Navy. And the market future also looks bright. According to a Congressional Armed Services Committee report in 2019, military services estimate that they will require upwards of 75,000 pilots over the next 20 years. And Boeing's 2018 pilot outlook indicates that North American companies will need to hire 206,000 new pilots over that same period. In terms of how we're going to reach this market, we're going to use a threefold approach to marketing. We're going to attend large aviation conferences with 2 attendees attending as both exhibitors and attendees. This will cost around $9,000. We also want to publicize, we also want to publish advertisements in large aviation magazines for about a quarter-size page for about $13,000. And most crucially, we wish to perform in-person sales demonstrations targeting the largest flight schools in each state, which will cost about $40,000. Now, if we assume we obtain an additional 2,500 subscribers as a result of this marketing effort, given the total cost, we have a customer acquisition cost of about $24. In terms of figuring out lifetime value for a particular customer, we've broken up into roughly 3 segments here. For an individual where we have a pro or a basic license, we'll have about an $1,800 lifetime value or $1,400 for the basic. And what we're most specifically targeting would be a typical flight school, where if we include a pro bundle, which could include 4 licenses plus an administrative version, we would have an initial hardware cost of about $500. A subscription for the bundle would be about $1,400 annually, a 90% retention rate, a profit margin of about 43%, and an average lifetime of the customer about 10 years, we would get about $59,000.
And so to talk a little bit about our customer discovery process, we began with this business model canvas in October of 2020. There's a lot here, but for the sake of time, we'll focus in on key partners because that's an area that changed quite a bit. So our key partners, as initially listed, included military acquisition, military research and development, civilian flight schools, and compatible flight training technologies. Since October 20, we've conducted more than 80 total user interviews to include 46 Army aviators, instructor pilots, standardization pilots, maintenance test pilots, and more across 3 different airframes, and 7 civilian pilots, all of which were certified flight instructors for both rotary wing and fixed wing aircraft. There are a number of different unit logos and organization logos listed here. These represent some of the different organizations that we had conversations with, and they include Charlie Company 325, Lightning Dustoff in Hawaii, Army Futures Command, General Dynamics, and Georgia Tech. And so there's quite a few lessons learned, but a couple of the ones I want to point out include that once we actually had conversations with instructor pilots, we realized that the technology that we had developed really for training purposes could also double as a standardized way in which to objectively grade check rights or flight exams for students. That's because our technology can realize whether or not certain standards have been met. And again, because those maneuvers are the basis of those check rides, that makes standardizing those check rides very easy. We also developed a better understanding of the military science and technology ecosystem, as well as funding opportunities available to us to include select SBIRs. We also realized that we needed an airworthiness release, also known as an AWR, in order to allow AURA and military aircraft for unit testing, and that we could actually attain this AWR through a cooperative research and development agreement with specified Army labs. And so here's a refined version of our business model canvas. Taking a look again at key partnerships, we see a new level of granularity. Particular partners of note include Air Force Works, the United States Army Aeromedical Research Lab, which is in Fort Rucker, Alabama, Army Futures Command, AF Ventures, Program Executive Office Aviation, 25th Infantry Division Combat Aviation Brigade, X-Tech Search, and Naval X. And in truth, these are actually only a few of the organizations we realize that could be of great help to us as we continue to develop a product that is not only an excellent technical product, but a product that actually helps and supports consumers in the way that they need. And so just for context, here is a roadmap of what we've done and what we're looking to do. Currently, of course, here in spring and summer 2021, you can see some of the items have already been accomplished. We've already developed a minimum viable product. We've conducted a feasibility study on the UH-60 Alpha Lima, which has steam gauges rather than a glass cockpit. We've also filed our provisional patent application. And looking forward, we look forward to securing a CRADA or a cooperative research and development agreement with USROL, commencing testing, integrating higher level tasks, filing a non-provisional utility application, and securing an AWR so that we can actually begin rollouts at different military units. And so our vision is reimagined flight training, leading to more capable pilots and safer skies. We're looking to target flight schools, military units, airlines, and individual pilots. And we hope to improve check ride pass rates, standardize maneuver grading, and ultimately reduce the incidence of aircraft accidents. Thank you for listening to our presentation. Purdue University has a long and proud history in aviation, and we hope that the AURA training system that we've developed can add just a little bit to that legacy. Thank you very much.